Question 1. In the context of securing applications in a cloud-native environment, Priya's organization is adopting containers and orchestrating them via Kubernetes in OS X. She notices that although traditional security tools provide perimeter protection, they do not monitor workload behavior. To enforce least privilege, Priya decides to deploy CloudGuard workload protection, which action best ensures that unauthorized behavior is blocked at runtime. Integrate OS WAF to monitor ingress traffic to the X cluster. B. Create allow lists based on observed workload behavior and apply runtime protection. C. Limit role permissions for containerized services only at deployment time. D. Use CloudGuard posture management to run periodic compliance checks. Answer. Correct answer. B. Create allow lists based on observed workload behavior and apply runtime protection. Explanation. Runtime protection in CloudGuard workload protection observes workload behavior and creates allow lists which act as behavioral baselines. These lists block any unexpected actions, ensuring true least privilege enforcement. Traditional IAM controls, C or WAF state offer control at ingress identity levels, but don't enforce from behavior. CCCS. D checks for compliance, not live behavior. The key concept is that container runtime protection is not about identity or traffic, but the behavior of applications in execution as supported by CNAPP guidelines. Question 2. When faced with designing a hard deployment for CloudGuard gateways in Microsoft Azure, architect Samuel must ensure both availability and correct session failover between nodes in different availability zones. What is the most appropriate method to ensure failover and IP continuity? A. Use Azure Application Gateway to distribute load across CloudGuard nodes. B. Assign public IPs to each node and configure manual failover scripts. C. Use Azure Load Balancer with floating IP support and configure clustering. D. Deploy gateways in the same as and use Azure Front Door for traffic routing. Answer. Correct answer. C. Use Azure Load Balancer with floating IP support and configure clustering. Explanation. For HA in Azure, CloudGuard supports an active passive cluster model with Azure Load Balancer, ALB, in front. ALB with floating IP. Direct server return allows seamless failover. A manual failover. B is error-prone and not scalable. Azure Application Gateway A operates at Layer 7 and isn't optimized for Layer 3 failover used by checkpoint clusters. Azure Front Door D is global and not designed for zone-based failover. Per checkpoint hard documentation, ALB with floating IP is required for failover and IP consistency. Question 3. To better understand traffic flow analysis in a hybrid environment, Annika's team deployed CloudGuard gateways in OS and connected them to an on-premise data center using VPN. However, she observes the east-west traffic within OS subnets is bypassing inspection. What should Annika do to enforce security on intra-cloud traffic? A. Use OS Transit Gateway to route all east-to-west traffic through the on-prem CloudGuard. B. Attach security groups to each EC instance to restrict east-to-west flows. C. Configure VPC routing to send in VPC traffic through a CloudGuard gateway using route tables. D. Rely on NACLs to monitor traffic across subnets. Answer. Correct answer. C. Configure VPC routing to send in VPC traffic through a CloudGuard gateway using route tables. Explanation. CloudGuard can inspect east-to-west traffic only if VPC routing is explicitly configured to direct traffic through it. By default, OS allows intra-subnet traffic to flow directly. Using route tables, C to route east-to-west traffic through the gateway enables inspection. Transit Gateway is ideal for PPC or hybrid routes, not intra-subnet. Security groups and NACLs. B. D. Control access but do not offer visibility or inspection. OS design allows route manipulation via transit routing and VPC peering for this use case. Question 4. As a result of increased regulatory pressure, Gabriel needs to validate that their OS infrastructure adheres to CIS benchmarks. He plans to use Checkpoint CloudGuard Posture Management (CCPM) for this purpose. What feature should Gabriel primarily use? A. Custom rules IGSL to detect EC over-provisioning. B. Threat emulation blade to scan EC images. C. Compliance engine for predefined frameworks like CIS, ECI, and NIST. D. Identity awareness for fine-grained user access monitoring. Answer. Correct answer. C. Compliance engine for predefined frameworks like CIS, PCI, and NIST. Explanation. CloudGuard posture management includes a compliance engine that allows Gabriel to validate cloud configurations against predefined benchmarks like CCCS. This is central to CPM's value proposition. GSLA is for custom policies, not predefined ones. Threat emulation. B is for malware, not compliance. Identity awareness. D deals with access control, not configuration compliance. The CIS framework mandates automated tools for continuous validation, which the compliance engine fulfills. Question 5. The underlying principle of the shared responsibility model is often misunderstood. Which of the following scenarios best illustrates the tenant's responsibility in a platform as a service PaaS model? A. Ensuring the physical security of the cloud data center. B. Updating the host operating system kernel. C. Securing application-level configurations and business logic. D. Managing the hypervisor and virtual network appliances. Answer. Correct answer. C. Securing application-level configurations and business logic. Explanation. In a PaaS model, the provider manages OS, runtime, and infrastructure. The tenant is responsible for the application code, logic, configurations, and user data security. Physical security. A. OS patching. B. And hypervisor. D. Are handled by the provider. Misunderstanding this leads to gaps in security coverage. As per OARS and GCP shared responsibility documentation, application-level controls remain the customer's duty even in higher abstraction services like PaaS. Question 6. Given the circumstances, Lisa has deployed CloudGuard AppSec to protect a set of APIs exposed through Azure API Gateway. She wants to ensure that only authorized users access sensitive endpoints and any anomaly in request patterns is flagged. Which feature of CloudGuard AppSec should she focus on? A. IP allow listing for fixed source IPs. B. Behavioral anomaly detection using AI-based models. C. NAT traversal support for legacy applications. D. Encryption of data at rest in cloud storage. Answer. Correct answer. B. Behavioral anomaly detection using AI-based models. Explanation. CloudGuard AppSec uses AI-driven behavior analysis to detect threats such as API misuse, injection, or data exfiltration. Static controls like IP allow listing A are inflexible for modern microservices. NAT traversal. C. And encryption at rest. D. Are unrelated to real-time API protection. OWASP top 10 API security threats, e.g. broken authentication, excessive data exposure, are addressed by AppSec via adaptive behavioral security, which Lisa can leverage for her API gateway integration. Question 7. By evaluating a recent CloudGuard deployment in GCP, Thomas notices that inbound traffic to where masses through the CloudGuard gateway, but outbound traffic is not inspected. What configuration is most likely missing? A. Enabling VEC service controls on the GCP project. B. Configuring a static NAT rule on the CloudGuard gateway. C. Associating the route tables for the subnet to point default traffic to the gateway. D. Defining an identity-aware proxy IP for traffic inspection. Answer. Correct answer. C. Associating the route tables for the subnet to point default traffic to the gateway. Explanation. For outbound traffic to be inspected in GCP, routing must be configured so default 00000 traffic flows through CloudGuard. This involves updating subnet route tables. VPC service controls. A. Restrict access but don't route traffic. NAT rules. B. Manage address translation, not routing paths. D is for user authentication, not traffic routing. Checkpoints GCP documentation stresses explicit route configuration for traffic visibility in both directions. Question 8. Taking into account the flexibility of cloud automation, David wants to deploy a checkpoint CloudGuard IaaS gateway stack using infrastructure as code in Azure. Which deployment option aligns best with native Azure tooling? A. OS CloudFormation template with ARM converter. B. Azure Resource Manager ARM templates for direct deployment. C. Google Deployment Manager scripts modified for Azure. D. Terraform CloudGuard provider for VMware SS. Answer. Correct answer. B. Azure Resource Manager ARM templates for direct deployment. Explanation. In Azure, ARM templates are the native infrastructure as code solution used to deploy CloudGuard IaaS gateways. OS CloudFormation and Google DMC cloud-specific and incompatible. Terraform D can be used across clouds, but the question emphasizes native tooling. As per checkpoint deployment documentation, official templates for ARM are provided for automated and consistent deployments in Azure. Question 9. Contrary to popular belief, integrating identity awareness in cloud environments doesn't require complex LDAP trees. What is fundamental benefit of using cloud-native identity services like Auzium or Azure AD with CloudGuard? A. It allows for VPN tunneling without certificates. B. Enables dynamic policy enforcement based on user roles and tags. C. Replaces the need for firewall policies entirely. D. Automatically patches cloud workloads during login sessions. Answer. Correct answer. B. Enables dynamic policy enforcement based on user roles and tags. Explanation. CloudGuard integrates with cloud-native identity services to apply identity-based access controls. This allows dynamic role and tag-based policy enforcement, improving agility and security. VPN, A. Patching. D. Or firewall replacement. C. Are not related to identity awareness. Per the Zero Trust model, identity is central. Dynamic policies aligned with cloud identity services ensure least privilege and conditional access. Question 10. Across different scenarios, security teams struggle to secure traffic between cloud regions. Julia manages a multi-region OS deployment and needs to inspect inter-region traffic flows. What is the most efficient architecture for CloudGuard deployment in this case? A. Deploy centralized CloudGuard gateways in one region and route traffic from all others. B. Use OS network firewall for all east-to-west inspection and eliminate CloudGuard. C. Deploy CloudGuard gateways in each region and use transit gateway peering. D. Rely solely on security groups to restrict inter-region flows. Answer. Correct answer. C. Deploy CloudGuard gateways in each region and use transit gateway peering. Explanation. For multi-region visibility and inspection, deploying CloudGuard gateways in each region and connecting via transit gateway peering allows low latency and scalable security. Centralized inspection adds latency and potential bottlenecks. Was network firewall. B. Is not checkpoint and may not offer unified policy management. Security groups. D. Are useful but cannot inspect or analyze traffic. This model aligns with Checkpoint's reference architecture for scalable multi-region cloud deployments. Question 11. The effectiveness of identity-based security policies is often debated in hybrid cloud environments. Jamal's organization uses CloudGuard identity awareness with Azure AD. He notices that policies based on user roles are inconsistently applied. After further investigation, he realizes federated identities are not being fully recognized by CloudGuard. What is the most likely cause? A. The policy is missing IAM-role bindings in Azure resource groups. B. Azure AD lacks integration with third-party SAML providers. C. CloudGuard was not granted permission to read user and group metadata. D. The organization has not enabled MFA for conditional access policies. Answer. Correct answer. C. CloudGuard was not granted permission to read user and group metadata. Explanation. To enforce identity-based policies, CloudGuard needs permission to access Azure AD user group metadata via API without proper app registration and required permissions. Graph API role-based decisions fail. MFA-D enhances security but doesn't affect role identification. In bindings, they apply to Azure roles but not external enforcement. SAML. B. Supports federation, but the problem here is API eval access. CloudGuard relies on cloud-native identity integration, as outlined in Checkpoint's identity awareness deployment docs. Question 12. From a practical standpoint, Noah is configuring CloudGuard for an organization with hundreds of OAuth accounts. He wants to ensure continuous compliance and centralized management across the cloud estate. What feature of CloudGuard posture management best supports this use case? A. Onboarding accounts using automated cloud formation stacks and master member linkage. B. Running individual compliance scans manually in each OAuth account. C. Enabling threat intelligence feeds for each account separately. D. Deploying per-region CloudGuard gateways in all OAuth regions. Answer. Correct answer. Onboarding accounts using automated cloud formation stacks and master member linkage. Explanation. CloudGuard CCCM supports multi-account onboarding using master member architecture via CloudFormation stacks, allowing unified visibility and policy enforcement. Manual scans, B, are inefficient. Threat intelligence, C, is useful but unrelated to CCPM onboarding. Deploying gateways, D, secures traffic but doesn't compliance or posture visibility. Per checkpoint documentation, CCPM enables central compliance across cloud estates with automation and scaling support. Question 13. To illustrate this point, Emma's organization deployed a CloudGuard security gateway in GCP. While inspecting the logs, she noticed outbound traffic to no malicious it wasn't being blocked. The threat prevention blades were enabled. Where's the most probable misconfiguration? A. The threat prevention policy wasn't installed on the gateway. B. Smartiver was disabled, preventing alert generation. C. The gateway was deployed in private VPC subnet. D. VPN tunnels were misconfigured, bypassing traffic. Answer. Correct answer A. The threat prevention policy wasn't installed on the gateway. Explanation. Enabling blades is not sufficient. Policies must be explicitly installed. Without installation, threat signatures won't be enforced. Smart event. B is for visibility, not prevention. VPC subnet placement. C doesn't block inspection. VPN tunnels. D might redirect traffic. But here the key issue is policy enforcement fundamental check. Operation requirement. The management server must install policies onto the gateway for blade functionality to take effect. Question 14. According to recent studies, organizations adopting multi-cloud face difficulties maintaining consistent security policies. Jacob, a cloud architect, wants to streamline policy enforcement across ORs and Azure using Checkpoint CloudGuard. What strategy best achieves this? A. Manually replicate security policies in both environments. B. Use CloudGuard's unified security management platform to centrally manage policies. C. Rely on OR's Security Hub and Azure Defender integration alone. D. Apply local policies and create shared spreadsheets to track them. Answer. Correct answer. B. Use CloudGuard's unified security management platform to centrally manage policies. Explanation. CloudGuard offers centralized policy management for multi-cloud via Smart Console, enabling consistent enforcement. Manual A or spreadsheet-based D management is inefficient and error-prone. Or Security Hub and Azure Defender C offer native protection but lack cross-cloud orchestration. The Checkpoint solution aligns with policy as code and cloud security posture management principles advocated by industry best practices, e.g. NIST CSF. Question 15. While examining the deployment options for CloudGuard in ORs, Olivia is tasked with configuring traffic inspection for east-west flows within. The E-ish method should she choose to ensure this is handled efficiently. A. Deploy the gateway behind an internal network load balancer with routing adjustments. B. Use OR's Route 53 to redirect internal DNS queries to the CloudGuard gateway. C. Enable Security Hub to automatically redirect traffic for inspection. D. Use OR's Shield to enforce internal traffic control. Answer. Correct answer A. Deploy the gateway behind an internal network load balancer with routing adjustments. Explanation. To inspect east-west VPC traffic, traffic must be routed through a CloudGuard gateway using custom routing and an internal NLB. Out 53 B handles DNS, not traffic outing. Or Shield D focuses on DDoS, not internal flow control. Security Hub C is for visibility and doesn't manipulate routing. Per OR's plus checkpoint guidance NLB with custom routes is the correct pattern for VPC internal traffic inspection. Question 16. The prevailing attitude toward automation in cloud environments has led Ethan to explore Checkpoint support for cloud-native automation. He plans to automate deployment of CloudGuard IaaS in GCP. What tool should he use for native deployment automation? A. OR's CloudFormation. B. Google Deployment Manager. C. Terraform for on-premises data centers. D. Azure ARM templates. Answer. Correct answer. B. Google Deployment Manager. Explanation. In GCP, Deployment Manager is the native automation tool supported by CloudGuard for deploying IaaS gateways. CloudFormation A is OR-specific. ARM D is Azure-specific. Terraform C is multi-cloud but not native to GCP. Deployment Manager supports repeatable, template-driven deployments aligned with Google Cloud's automation strategy. CloudGuard offers pre-built templates for this. Question 17. In the absence of proper container image control, vulnerabilities can enter production environments. MIA manages a Kubernetes cluster on G-key. He wants to ensure all deployed containers pass security validation before runtime. Which feature in CloudGuard helps enforce this? A. Runtime protection of pods during execution. B. Identity awareness for GCP in roles. C. Admission control for image security validation. D. Outbound traffic filtering via network policies. Answer. Correct answer. C. Admission control for image security validation. Explanation. Admission control in CloudGuard allows pre-deployment image validation, ensuring only approved, vulnerability-free images run. Runtime protection. A. Works after deployment. In roles. B. And outbound policies. D. Don't control image admission. Kubernetes security best practice. CCCS recommend image scanning during admission to prevent insecure workloads. CloudGuard integrates with Kubernetes API server to enforce this via webhook admission controllers. Question 18. As evidenced by repeated misconfigurations in network security groups, Lucas wants to perform deep analysis of VPC network configurations using CloudGuard CCM features. Which tool or capability should he use? A. GSL queries to analyze rules across cloud environments. B. Threat emulation blade to scan network interfaces. C. VPN diagnostic tool within Smart Console. D. ClusterXL to monitor traffic patterns. Answer. Correct answer. A. GSL queries to analyze rules across cloud environments. Explanation. GSL, governance specification language, enables CloudGuard users to define custom logic to detect misconfigured security groups, open ports, non-compliant rules, etc. Emulation blades. B. ClusterXL. D. Or VPN diagnostics. C. Are unrelated to posture analysis. GSL is a query-based engine built for flexible compliance and risk analysis, ideal for scenarios like Lucas's. This aligns with CloudGuard's intelligence feature suite. Question 19. The most significant aspect of DLP configuration in cloud environments is controlling sensitive data exfiltration. Sarah enables the DLP blade on her CloudGuard gateway in Azure but notices it fails to trigger alerts. What must be done to ensure proper DLP functionality? A. Configure DLP templates and assign them to relevant rules in the policy layer. B. Enable the application control blade instead of DLP. C. Use threat emulation to inspect all outbound documents. D. Connect Smart Event to external mail filtering services. Answer. Correct answer. A. Configure DLP templates and assign them to relevant rules in the policy layer. Explanation. DLP requires both blade activation and assignment of templates to policies without linking the DLP policy templates. E.g. for credit cards, PI, the blade has no criteria for triggering alerts. Application control. B. And threat emulation. C. Are different blades with distinct purposes. Smart Event. D. Offers visibility but not enforcement. Check PDLBlair. Acquire template rule binding for DLP to function. Question 20. The core principles of high availability include session persistence and fault tolerance. In designing a multi-as deployment in ORS, Aaron wants to ensure minimal downtime. What is required for a valid hard CloudGuard setup? A. Standalone gateways with auto-scaling groups. B. Cluster CloudGuard gateways with elastic IP failover and sync. C. Centralized gateway, one as with DNS round robin. D. Using multiple NAT gateways to load balance sessions. Answer. Correct answer. B. Cluster CloudGuard gateways with elastic IP failover and sync. Explanation. ORS hard deployments for CloudGuard require active passive clustering, elastic IP assignment, and state sync to maintain connections. Auto-scaling A applies to stateless services. DNS round robin. C. Lacks real failover. NAT-based. D. Methods don't preserve session state. Checkpoint uses ClusterXL and CloudFormation templates to automate high NORs, ensuring both availability and security continuity. Question 21. Throughout the course of their cloud adoption, Isabella's team has adopted CloudGuard workload protection to improve their DevSecOps pipeline. They use Kubernetes clusters in OS X and want to prevent vulnerabilities from reaching runtime. What is the best approach to enforce pre-deployment security controls? A. Enable runtime threat prevention and allow auto-blocking during execution. B. Applied mission control to validate container images before deployment. C. Configure VPC service endpoints to restrict internet access. D. Use identity awareness to detect unauthorized users. Answer. Correct answer. B. Applied mission control to validate container images before deployment. Explanation. Mission control ensures container images are scanned before deployment. It acts as a gatekeeper, preventing insecure containers from running. Runtime protection is reactive, not preventive. VPC endpoints. C. Help reduce external exposure but not image validation. Identity awareness. D. Controls access, not workload support. CloudGuard's Kubernetes security documentation. Admission control is first line of defense in shift-left security. Question 22. In response to frequent cloud resource misconfigurations, Oman decides to implement custom compliance policies across ORSA GCP. He chooses CloudGuard Posture Management for this task, which feature enables him to write custom rules tailored to his organization's internal security standards. A. Smart Console Rule Editor. B. Compliance Engine's Default Benchmark Editor. C. Governance Specification Language GSL. D. Identity Awareness Mapping. Answer. Correct answer. C. Governance Specification Language GSL. Explanation. GSL allows custom rule creation in CloudGuard Posture Management to detect misconfigurations or violations against internal standards. Smart Console A is for managing firewalls. The compliance engine's default rules. B. Supports SIS, NIST, etc., but not custom logic. Identity awareness. D. Is unrelated. Per checkpoint documentation. G. Enables writing human-readable rules like ORS EC instance. PubSip exists, making it powerful for bespoke compliance. Question 23. Contrary to popular belief, relying solely on IAM policies is insufficient for full cloud workload protection. A security analyst, Felix, observes that an ORS Lambda function in his environment accesses their buckets it shouldn't. IAM roles appear correctly configured. What CloudGuard capability can help prevent such unauthorized access dynamically? A. Enabling network shackles to restrict outbound traffic. B. Using CloudGuard identity awareness to apply real-time role-based access enforcement. C. Using Security Hub alerts to block access manually. D. Disabling CloudTrail logging for Lambda functions. Answer. Correct answer. B. Using CloudGuard identity awareness to apply real-time role-based access enforcement. Explanation. CloudGuard's identity awareness allows policy enforcement based on cloud roles and tags. Even if IAM roles appear correct, runtime access patterns can still expose misconfigurations. NACLs A don't handle identity-based policies. Security Hub C is for visibility, not enforcement. Disabling logging D is misstep. CloudGuard bridges the identity to enforcement gap in dynamic environments, aligning with zero trust principles. Question 24. The correlation between misconfigured firewalls and public exposure is clear in many cloud breaches. Sarah manages security for a multi-account ORS structure. She wants to ensure real-time detection and remediation of overly permissive security groups. Which CloudGuard feature should she leverage? A. CloudGuard Gateway's VPN logging capability. B. CloudGuard Posture Management's real-time misconfiguration monitoring. C. Threat Emulation Blade on outbound traffic. D. Terraform State Inspection. Answer. Correct answer. B. CloudGuard Posture Management's real-time misconfiguration monitoring. Explanation. CCM detects real-time misconfigurations like open security groups and can trigger alerts or automatic remediation. VPN logs A are not relevant. Threat emulation C analyzes malware, not configuration. Terraform inspection D helps if using infrastructure as code but lacks live posture insight. CP Intelligence Engine evaluates cloud-native configurations continuously as recommended by NIST 80053. Question 25. From a historical standpoint, security operations lacked visibility into east-west traffic in public cloud environments. Now, Ben is tasked with inspecting internal traffic in an Azure-based application using CloudGuard. What network architecture must be in place to achieve this? A. Connect Azure VNet peering directly to the on-prem data center. B. Use Azure Application Gateway in Layer 7 inspection mode. C. Route internal subnet traffic through a CloudGuard VM owing others. D. Configure SCDS to enforce logging of traffic. Answer. Correct answer. C. Route internal subnet traffic through a CloudGuard VM owing others. Explanation. To inspect east-west traffic, user-defined routes others must be used to route internal traffic through CloudGuard. Application Gateway B operates at Layer 7, not suitable for LL flows. ADSD offer control but not inspection. VNet peering A lacks traffic inspection. CloudGuard documentation for Azure outlines other-based inspection as a core architecture for east-west visibility. Question 26. By comparing CloudGuard AppSec with traditional WAFs, Leo wants to understand its advantage in protecting dynamic cloud-native APIs. What is a distinct feature of CloudGuard AppSec that enhances API accuracy? The integration with third-party DLP tools. B. AI-based learning of API behavior for anomaly detection. C. TLS termination proxy for encrypted traffic. D. Web scraping protection based on rate limits. Answer. Correct answer B. AI-based learning of API behavior for anomaly detection. Explanation. CloudGuard AppSec uses AI to analyze API traffic patterns and detect anomalies like credential stuffing or misuse of sensitive endpoints. DLPA is for data protection, not API behavior. TLS proxies, C, assist inspection but are not AppSec's core advantage. Rate limiting, D, is useful but not AI-driven. CloudGuard's adaptive model. Beyond static WAF rules as endorsed by OWASP API security recommendations. Question 27. In what ways can automated remediation improve security posture in cloud environments using CloudGuard posture management? Joanna wants to automatically fix non-compliant storage buckets. What is the correct method? A. Use predefined actions in GSL that trigger remediation scripts. B. Block access to all non-compliant users until manual fix. C. Generate alerts but rely on human intervention. D. Configure firewalls to prevent storage bucket access. Answer. Correct answer A. Use predefined actions in GSL that trigger remediation scripts. Explanation. GSL not only detects misconfigurations but also allows automated remediation through predefined actions like auto-closing public sockets, blocking users. B. Causes unnecessary disruption. Alerts without automation. C. Delay resolution. Firewalls. D. Don't directly protect object storage. Proactive, rule-based lines with compliance frameworks like CIS and ECSS. Question 20. The traditional approach to traffic inspection often misses serverless architecture activity. Hannah is using Ors Lambda extensively and wants to secure it with CloudGuard. Which method aligns best with protecting serverless functions? A. Attach a CloudGuard gateway in front of each Lambda trigger. B. Enable runtime protection using the CloudGuard agent. C. Place a WAF at the VPC boundary. D. Restrict IAM roles at the group level. Answer. Correct answer. B. Enable runtime protection using the CloudGuard agent. Explanation. CloudGuard supports runtime protection for serverless functions identifying malicious behavior during execution. Attaching a gateway is not feasible due to serverless's ephemeral nature. WAF C. Inspect traffic, not function logic. IAM roles D. Help but don't offer behavior-based protection. Serverless protection aligns with CNAPP principles, cloud native application protection platforms. Question 29. The development of scalable CloudGuard deployments across those regions is a challenge Liam must solve. What's the most efficient way to implement consistent network security across multiple regions? A. Use centralized CloudGuard deployment in one region for all traffic. B. Deploy CloudGuard gateways in each region and connect via transit gateway peering. C. Rely on all security groups to restrict cross-region flows. D. Use centralized NAT gateway for regional inspection. Answer. Correct answer. B. Deploy CloudGuard gateways in each region and connect via transit gateway peering. Explanation. For scalability and low latency, deploying regional CloudGuard gateways and connecting them via transit gateway peering ensures consistent, efficient security. Centralized gateways, they introduce latency and single point of failure. SGS-C don't offer deep inspection. NAT gateways D aren't designed for full traffic inspection. Per checkpoint reference architecture, multi-region deployment with peering is preferred. Question 30. With respect to VPN deployments, Norman is configuring a secure connection between his on-premises data center and a CloudGuard gateway in Google Cloud. What must he configure for? A resilient IPS VPN connection, a BGP routing over static VPN with Cloud NAT, B. Route-based VPN with dynamic routing BGP and HAR-tunnel configuration. C. Yes EAATF for compatibility. D. GRE tunnels inside IPsec for added redundancy. Answer. Correct answer. B. Route-based VPN with dynamic routing BGP and HAR-tunnel configuration. Explanation. Route-based VPN BGP offers dynamic routing and failover essential for high availability. CloudGuard supports VPN setups in GCP using two IPsec tunnels with BGP. Static VPN lacks agility. SOPN-C is not suitable for site-to-site tunnels. GRE over IPsec D is not natively supported in this scenario. Checkpoints of VPN setup aligns with Google Cloud's VPN recommendations.